Okay, so our next topic is about tautology. So a compound statement S is a tautology if the truth value of S is true for any assignment of truth values to the statement variables occurring in S. So let us try to understand what it means. So let us show that this compound statement P or not P is a tautology. Okay, so the P could either be false or true. Okay, so taking the negation of P, the negation of a P which has a value of true will be false. And if P is false, the not P is true. Okay, so now taking the disjunction of P or not P. So defining not P, it means that this will only be false if both of the statements are false. So if there is at least one true, then this will evaluate to true. Okay, so since P or not P, it has true and a false na value, so this will result to true, and false and true will also result to true because there are at least one na true na values. Okay, so this is considered as a tautology because the outcome of P or not P is all true. Okay, for all na possible combinations of P. Okay, so let us move on to the next example. So let's show that this compound statement not P or Q implies P is a tautology. So the first thing that we'll do is to look at the distinct variables in this statement. So we only have P and Q. So P and Q could have values true and true, true and false, false and true, and false and false. Okay, so we wanted to show that this statement is a tautology. That means that we are expecting that the results or all the possible outcomes for this compound statement is all true. So at the end, our result should be all true. So these are our expected. Okay, so let us try to prove that this is indeed a tautology. Okay, so looking at this, we will first evaluate the negation of P or the not P. So we will just negate all the values of P. So now the true comes false, and the false will be true. Okay, now let us look at the implication of Q and P. So Q is our hypothesis and P is our conclusion. Okay, so this will be, you look at this direction. Okay, so this will be our hypothesis and this is our conclusion. This is our conclusion. Okay, so this will only be false if the hypothesis is true and if the conclusion is false. So this will be false and the rest will be true. Okay, so that's the rule of implication. Okay, now let us combine this expression not P or the implication of Q and P. Okay, so let us look at these values. So first we have the false or true. So since this is again a disjunction, so this will result true if there is at least one true, and it will only be false if both are false. Okay, so in this case, there is no combination of this and this that are both false. And if we look at each of the rows, there is at least one true. So that means that the results of this will be all true. Okay, so false or true, true, false or true, true, true or false, also true, true or true, it will also be true. Okay, so now we have proven that this is equivalent to our expected outcomes, which are all true. So we have proven that this statement is indeed a tautology.